Hello, today we're going to be going over a problem which is commonly found in many interviews and some sort of lead code problem, kind of, which is to find the number of permutations of a smaller binary string in a larger binary string and also find the respective indices of each permutation. And for example, here we're giving a long string and a short string. They both only have two characters by the name binary, which in this case are ones and zeros, but they could also be A's and B's. Anything basically is a fair game as long as they just have two characters. And we need to find permutations of the smaller binary string in the larger long string. So what is a permutation? A permutation is just basically moving and mixing the characters in the shorter string, and you can come up with different things. Like for example, if you have the characters 110 for your short string, the permutations of that are going to be 110, 101, and 011. So this is going to be it for this specific case. However, while it might not be as evident, you do want to find some clever way to solve this. You don't want to brute force this, as permutations by very definition are O of n factorial. So yes, that can bring a lot of growth. It's going to take a long time even for a computer to find permutations of a string. So that's not the way you want to go. So clearly brute force is not the way to go, and what we're going to do is we're going to use a Python count function, and we're going to do this. We're going to store the count of the ones and the zeros. So we're going to call this one count in a short string, just to make that clear. And we're going to count for the character literal 1, and 0 count is going to do basically the same, but count the number of zeros. And so our basic strategy is going to be looping through windows in the long string. So we're going to have a window of length 3 characters. So for example, at first we're just going to go over these 3 characters, then we're going to go over these 3, then these 3, and so on. And basically we're going to find out all the permutations. So we're going to do a range-based for loop for I in range. We're going to start at range 0, and the end length is going to be the length of the long string minus the length of the short string, if I'm not mistaken, plus 1, I believe. And we're going to test this right now. We're going to get a substring, basically, that's going to act as our window. So let's declare that sub. And that's going to be a partition of the long string, going from I to I plus a length of short string. And what we can actually do, so that we're not calculating all these values over and over again, we can go short string length and declare that equal to the length of the short string, so that it's not going to change while we're doing that, so we might as well just get it out of the way, and we'll do the same for the long string. It can't hurt though. These little improvements tend to help a tiny bit when doing like some sort of lead code problem, because you don't want to be calculating this each iteration. Long. And now we can basically just substitute that in here. Short. And let's just double check that we're doing this right, and let's go ahead and print out a substring. And we'll see if this works. Here we go. So as you can see, we are looping through the entire long string, ending with the 3 ones, and here are the 3 ones. So now we can actually start doing some work. So our strategy is going to be to see if the substring that we have right here has the same number of ones and zeros as our short string earlier. So to do that, we can do if sub dot count of ones is equal to and substring dot count of zeros is equal to 0 count. We're gonna say we found it and we want to know which index we found it at. So we're gonna print from I to, just make it format nicely, I plus short string length. And if I didn't misspell anything, this should work. And just a little thing, we do want to have a variable that keeps track of how many permutations we're finding. So num per is going to be first initialized to 0, and if we do find a permutation, we just want to add 1 to that. And basically we're done here. I'm just going to go ahead and print out the number of permutations. So we're going to go ahead and run this. So there you go. We ran it, and we do get 3 permutations. It says that it's from 0 to 3. So that's going to be the first 3 indices, and as we can see, it is a permutation in fact. From 6 to 9, which is from here to here, and from 7 through 10, which is these 3 right here. I don't know if you guys can see my cursor. But essentially, what we did, just to sum it up, is we ran through a window of the long string and got a substring in each window, and we just counted numbers of 1s and 0s. And some of you that were clever enough to figure this one out, you actually only need to check for 1 because it is exactly the same since it is a binary string. So that's another trick to make it a tiny bit faster. And now we can discuss the time complexity of this a little bit. So now, to talk a little bit about the time complexity of this, it is going to depend on 2 things, and those 2 things are the length of the short string and the length of the long string. The length of the long string is what I would say influences it the most, and we do know that the length of a long string is usually going to be a lot longer than the length of a short string. So basically, the time complexity of this is going to be O of length of long string, which let's call ls, times the length of the short string. Why does the length of the short string matter? Because each iteration you're going to go getting a substring which has a specific window, and for each iteration you're going to loop with the count. You're going to go through this substring each iteration. So the longer the short string is, the longer it is going to take each round. So essentially that is why it is going to be O of ls times O of short string. Let's call that SHS. And basically, yeah, that is going to be the time complexity. I hope this video is intuitive, and I hope it does help everyone watching this to be able to solve some sort of problem similar to this one. It can be either in some sort of interview or in LeetCode, but I hope it really helped you guys.